In this video, we are going to be doing number 17 on page 141 of the AP Physics textbook. The distance between two telephone poles is 50 meters. When a 1 kilogram bird lands on the telephone wire midway between the poles, the wire sags 0.2 meters. Draw a free body diagram of the bird. How much tension does the bird produce in the wire? Ignore the weight of the wire. So, again, we always start these problems by drawing free body diagrams, which is what the problem wants us to do in the first place. Let me just zoom out here. Let's visualize what's happening first. So, before the bird lands, here's our telephone poles. Our wire looks like this. After the bird lands, our wire looks something like this. So I'm going to draw a bigger free body diagram. So the weight of the bird has a mass of 1 kilogram, which means its weight must be 9.8 newtons. And then we have 1/2 of the wire like that, another half of the wire like that, and of course it is making an angle with the horizontal. And we can actually easily figure out what that angle is. So the length here is 25 meters, and obviously this is not to scale. It says the wire sags 0.2 meters. And here is our angle. So you can find the angle by doing the inverse sine of 0.2 over 25, and you should get 0.459 degrees. Why does that help us? Well, we know that the y components of the two halves of the wire has to be equal to the weight of the bird, or else the bird would have broken the wires. So, in other words, let's call this T1 and this T2, and we know that T1 equals T2. So T1y plus T2y has to equal 9.8. And since we know that these two are equal, we know that 2T1y equals 9.8. Now, we know that the y component of the tension will be equal to the tension times the sine of the angle. So we need to do 2 times T1 sine of this 0.459 degree angle equals 9.8. So we just need to solve for T1. And if you multiply all these numbers together, you will get that 0.016 T1 is equal to 9.8. Divide both sides by 0.016, and you get that T1 is equal to 612.5 newtons.